Hi guys, welcome back. So in this video we're going to talk about the CSS box model, and the box model is crucial to understand if we're going to be able to create cohesive layouts and control how our pages are presented. So every element on a web page is rendered by the browser as a box, whether it's a paragraph, a heading, a button, a div, a span, a link or an image. Every single element on a web page is a box. So to be able to create good layouts, it's important to understand the properties associated with these boxes so we can manipulate them, making boxes bigger or smaller and changing the space inside or around them. The parts of the boxes are the content box, padding, border and margin, and in this video we're going to look at all of these different parts and how they work. We'll start by focusing on this inner box. This is the content box that is formed by the visual content of the elements. If I give this H1 a background color, we can see that there is a box, and if I drag this window, we can see that the box is taking up the entire line that it sits on, stretching the full width of the page. We discussed block level elements in the HTML section of videos, but to recap, a block level elements box stretches to fill the full width of its container by default. In this case, the container is the body element. An inline elements box only stretches to fit the size of the content. I can change the size of the content box using width and height properties. I could change the heading's width to say 350 pixels, and I can manipulate the height and let's say how about 75 pixels, and that is changing the inner content box itself. When we work with width and height, we have a couple of different measurement units that we can use. I'm using pixels here for simplicity's sake, but you could use percentages, ems, rems, VH and VW, as well as auto and inherit. And we'll get into CSS units a little bit later on in more depth, as it's its own topic really and deserves the attention of a full video. So for now we're going to stick to pixels to keep things simple and clear. But with width and height properties, these allow us to control the size of the box. The content box doesn't always have to be text. It could be an image or a video or something like that. I have two lovely images here of Troll Tunga in Norway from unsplash.com, which at the moment are a little bit too big for the page. The images are large enough that I'm having to horizontally scroll the page at the moment, and in general this is bad UI and it's something that we would always want to avoid as developers. The image is 1510 pixels wide and 1000 pixels tall. So if I set the width to say 5 times smaller than that, that's going to be 302 pixels, and we see the height automatically adjusts, and 5 times smaller than 1000 pixels in height is 200 pixels. We could add a height property of 200 pixels, and then we are explicitly setting it for clarity, but it really makes no difference if we add the height property or not. The image does not have a background color like H2 at the moment. Even if we set one, it won't appear. So let's say background color of orange, and when we save we see no change, and that is because the element itself is set to the size of its content, and in this case the content is the actual image itself, which is taking up the entire content box. If we remove the path to the image, we see that the content box holds its shape. It's now devoid of an image, but it retains its size, which we have explicitly set, and the background color is now visible. But interestingly, if I have an alt attribute here for this image, and let's put Troll Tunga, the content box actually changes size, and that's because the content on the web page is now text. Images are inline elements, so this alt text now is inline text. An inline element is an element whose width and height are determined by the content that it contains. Inline elements will completely ignore the width and height properties, as well as top and bottom margin properties. To illustrate this, I'm going to add another inline element, a span, to the H1 heading, and in this first paragraph I'll then add background so we can see the span. Now we can say height 1000 pixels and width 1000 pixels, and the span is completely unchanged. So if the content is text and the element is inline, then the content box ignores height and width properties. Its size is determined purely by what its content needs. The content box of block level elements can be manipulated, however, by setting height and width properties. Okay, so the next property of the box model is the border. We can set a border in a few different ways, and let's stick with the images for this one. I'll add the second images path back in for this and remove the background color property. I can set the border using the shorthand border property. We give it 3 space separated values, and these values control the border width, the border color, and the border style, and they don't have to be listed in any specific order. So that's the shorthand version of setting a border, and the one that you're probably going to use most of the time. But we can also use individual properties on the border. So if we check here at cssreference.io, we see that there are actually 26 CSS properties that are associated with borders. We could change the border to be dashed or just part of the border using border style dashed. We could also just change part of the border bottom style dash, let's say. We could set the border color, let's say border magenta, or we could have just an individual part of it, let's say border top color. We could also set the width of the whole border or even just one part of it. So let's just say border width of 30 pixels, but we could just change that, as I say, to one part of it. So let's say border right will be 30 pixels. We could even take a section of border away. So let's take away the left border and we'll just say border left, and we can set that to none. We could also set that to 0 and we get the same result. We can even curve corners by setting a border radius. So let's just add a normal consistent border back in. Let's say border 3 pixels solid and black. And now when I set border radius, let's say 10 pixels, we see that the corners are curved. If we set no border, then the border radius property is going to have the effect of curving the corners of the image or whatever element you've got border radius set to. So there are many ways of affecting the border, but it begs the question of why. I guess in most cases, if you are going to set a border, you're going to set a consistent border on all 4 sides, and the shorthand property is what you're going to need most of the time. If we inspect the image with DevTools and go to the bottom of the CSS panel, or alternatively to the Computer tab, we can see an image of the box model that shows something called padding between the border and the content box. Properties relating to padding are responsible for generating space around an element's content within the element's borders. Our image's content meets the border at the moment, and that's because we've not given it any padding. So let's say padding 20 pixels, and you see now we have this white space between the content and the border. So now we can hover over the box model in DevTools, and it's going to highlight the relevant section of the box. So we have our content in blue, the padding is this green color, and the border is showing up in this beige orange color, whatever you want to call that. As it's within the borders of the element, we can use background color to affect the padding. So we'll add that. And here we've used the shorthand padding property, but we could use separate properties to set padding individually on the top, right, bottom and left. We can see those here again on CSS reference, and this shorthand padding of 20 pixels is the same as writing padding 20 pixels, 20 pixels, 20 pixels, 20 pixels. We read these like a clock, starting from 12 o'clock and moving clockwise. So the first value here, the first number, is the top padding, and then we've got padding right, padding bottom, padding left. So it's top, right, bottom, left. Top, right, bottom, left. So let's remove the left and right padding, and we would change the values for right and left to 0 pixels. So as we've got a 0 here, we don't actually need to specify a unit. 0 pixels is the same as saying 0% or 0 at any other unit. So we can simplify again by removing the unit, and this looks cleaner. But as we now have matching values on the sides and matching values on the top and bottom, we can delete 2 of the values. So we've got 20 pixels and 0. And here we're breaking away from the clockwise pattern, and instead, when there are just 2 values, we read them as vertical padding, so that's the top and bottom, and horizontal padding. So there's many ways to write values with the shorthand padding property: as 1 unit if all values are consistent, as 4 separate values or as vertical and horizontal values. We can also add free values where the first and third value are the top and bottom, and the middle value is setting a horizontal value, but I tend to steer clear of that one because I find it slightly confusing for some reason. Like with border, we can use more specific properties to set individual paddings to the top, right, bottom and left. So if I go to the H2 here, I'll add some padding, and first I'll set it up so the text sits centrally. So we'll set it up with some Flexbox quickly. I'm not going to explain Flexbox here. I'll cover this in Flexbox videos a little later on the channel, but you can center text in this way. I'm also going to add a background color, and I'll give it a width of 130 pixels. So that's our heading setup, and when we add a padding of 50 pixels, we see that it stretches the background color. It may appear that the small content box has expanded here, but that isn't the case, and we can see that by inspecting it. The content box is still the dimensions that we set with the width property, and the padding is added on top of that. The background color spreads to color the content box and the padding, as they are both internal parts of the element within the border. We see that by hovering the element with this DevTools pointer arrow, how an element is formed by the box model. We see it has some margin applied, and this is a browser default style, and we can see that here in the computed values in the CSS panel. So DevTools can be really useful for figuring out what our elements are made up of and why they are being spaced out in the way that they are. So that's the basic idea of padding. It's essentially space internal to an element between the content box and the border. We can pass a single value when all sides match in size. We can specify all sides that we read clockwise from the top value, or vertical and horizontal values. We can also set padding on specific sides, and you can see the properties here on cssreference.io, and I'll let you experiment with these in your own time. Okay, so let's look at margin, which is the space between one element and other elements on the page. It sits on the outside of the other parts of the box model that we've seen so far. We can add a margin surrounding all four sides of an element with a margin shorthand property, and this works just like the padding shorthand property, where we add a single value to set the same consistent margin on all four sides of the element. We can also set 4 separate individual values for top, right, bottom and left, and we would read these again in a clockwise direction, or we can set it just to 0, just like padding. We also have separate margin top, margin right, margin bottom and margin left properties, as we see here on cssreference.io again. So back here in CodePen, we'll add a margin to the images, and I'll set a single value to add a consistent margin on all four sides, and I'll set that to a margin of 30 pixels. You see that the images are spaced out vertically, and if we inspect them with DevTools, you can see that the margin is highlighted here in this orange color. In between the images now is 60 pixels of space, that is vertically, and if I drag the DevTools panel over, horizontally too. So the margin acts as a buffer around an element, creating a bit of space around it. As we said, we can set margin specifically on one side individually, or 2 or 3 or 4 sides. So let's take the H1 element and we'll set a margin bottom to be 150 pixels, and you see that it pushes everything else below, creating more space. I can also set a margin left on the H2 elements, and we'll set that margin left to be 100 pixels, and you see that it shifts over from the edge of the page. Again, I can pass in 2 values for vertical and horizontal margins, so let's use these paragraphs to illustrate that. I'll do 20 pixels vertically and 50 pixels horizontally, and if we inspect that with DevTools, you see that quite clearly. I could also use 4 separate values here to set individual margins on all sides if I wanted to, but I think you're fairly familiar now with the idea, as we've already seen that in use when we looked at padding. It works exactly the same with margin. The properties are here for your reference at cssreference.io, so have a look and have a little experiment and try those out yourself. So instead of looking at that, let's give the same margin value we just gave to the paragraphs to the H2 elements, and we're going to talk about a concept called margin collapse. So margin collapse is where the margins of block level elements are sometimes combined together or collapsed into a single margin that separates them. The size of the margin is the largest of the individual margins that are being collapsed, or just one of them if the margins are equal. So this is a behavior, again, known as margin collapsing. The H2 and P elements here are both block level elements, so perfect for us to check that out on. And if we look at them in DevTools, you'll see that their margins are actually collapsed into each other, as the margins here are both 20 pixels, rather than there being a 40 pixel margin between them. There's only actually a 20 pixel margin. If I change the H2 to 50 pixels, making a larger margin, you can see that the gap between the elements is 50 pixels, not 70. Coming from the 50 pixels, add 20 pixels. It doesn't add the two to create the gap of 70. It takes the larger of the two margins, which is 50 pixels in this case, and makes it the space between these two block level elements. This only works on vertical spaces, so only vertical margins collapse on adjacent elements, and these paragraphs and H2s are all adjacent to one another. The images below are also adjacent to one another, but they're actually inline elements, and inline elements do not respect vertical margins. So we see the P elements margin and the images margin are not going to collapse. So the space is 50 pixels, which is 20 from the paragraph and 30 pixels from the image. Neither do the two images margins collapse into each other. Space between them is 30 plus 30 pixels, which is 60 pixels in total. So that's the basics of the box model covered. What we're going to look at to finish up is box sizing, which gives us different ways to calculate how box or element size is calculated. Box sizing allows us to change how the width and height properties are calculated for an element. So if I add a hover pseudo class to the image, and let's add a thicker 5 pixel border, and you're going to see that when I hover over the images now, we get this weird jerky layout shift happening, and this is pretty weird and not something that we want happening on our web pages. We want to see a consistent and cohesive layout to anything that we build, and the reason that this behavior is happening is that we have our width of 302 pixels, and the border is then being added on top of that when we hover. So 5 pixels on each side, and that extra space added to the elements is pushing everything else around it into different positions. But we can change how the size of the boxes are calculated and stop this behavior from happening. We can use the box sizing property to change how the browser calculates height and width. The box sizing property is already applied as a browser default to the images. It's set to a value of content box. I can set that explicitly to the image selector. I think the shortcut is BXC. Yep. And when we hover, we still have that same behavior occurring when we hover the images. If I change that now from content box to border box, we see first of all our image size totally changes. And then when we hover, there's no shifting happening to the other elements on the page. They stay static. The change is only happening to the content of the content box. And we can see that if we look at the box model diagram in DevTools, we now have a 292 pixel width. So we've got the two 5 pixels here, and that is our 302 pixels when added together with the content. Then we've got 150 pixels height in the content box, plus 2 times 20, and then 2 times 5 pixels, and that makes up our 200 pixel height. So we're saying that the width and height of the entire image is going to be the content box plus the padding and the border added on top of that. So when we say 302 pixels, that's the absolute total width of the border box. It measures how much border and padding you have, then calculates how much room is left for content based on those numbers. This is useful not just for hover effects, it can be used in general if you're just trying to make something a given size. Perhaps you know that you need an element to be exactly some size, and you want to set it to border box to guarantee it's the size that you're setting. You can even add a CSS reset or perhaps a universal selector with a box sizing property set to border box, so that all elements are then calculated as border box. which means we're not going to have to do maths later on figuring out how big things actually are and why something is overflowing one way or another. If we have a width of 300 pixels set to an element, if we do have a reset or a selector in place, then we could be confident that the element is going to be 300 pixels wide. Okay, so that's pretty much it. We know that all elements are boxes, and these boxes are made up of content, padding, borders, and margin. We can space elements using these properties, and we know how to control the size of elements and how the browser is calculating size. In the next video, I think we're going to look at the display property next, and this affects how elements behave. We know how block and inline elements behave. We've learned a little bit about them in the HTML section, and in the next video, if we do this display property, we'll take a look also at inline blocks and also possibly at flex and grid elements a little bit as well. Links to the resources used in this video are in the description below, plus some other info. If you want to follow us on socials, etc., it's all underneath. So thank you very much for watching. I do appreciate it, and I'll see you in the next one.